ಸಂದೀಪ್ ಸರ್. ಹಲೋ. ಹಲೋ. ಸಂದೀಪ್ ಸರ್.
Hello sir, can you hear me sir?
ಎಸ್ ಸರ್.
Yes,
ಸರ್,
sir.
ಹುಡುಗರು ಜಾಯ್ನ್ ಆಗ್ತಿದ್ದಾರೆ ಇವಾಗ.
Yes sir.
ಶಾಲ್ ವಿ ಸ್ಟಾರ್ಟ್ ಇನ್ ಅನದರ್ 2-3 minutes?
Yes sir. Yes sir. Yes sir. As your choice.
ಥ್ಯಾಂಕ್ ಯು. Shall we begin, sir?
Yes, sir. Yes, sir.
Yeah. ಇಂದಿನ ಪ್ರತಿಭಾಶೋಧನ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಆಗಮಿಸಿದ ಎಲ್ಲರಿಗೂ ಕರ್ನಾಟಕ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಅಕಾಡೆಮಿಯ ಪರವಾಗಿ ಸ್ವಾಗತವನ್ನು ಬಯಸುತ್ತಾ ಇಂದಿನ ಉಪನ್ಯಾಸ ಮಾಲೆಯನ್ನು ಡಾಕ್ಟರ್ ಮೊದಲಿಗೆ ಮಿಸ್ಟರ್ ಸಂದೀಪ್ ಕುಮಾರ್ ಸತ್ರಶಾಲಾ ಇವರು ನೀಡಲಿದ್ದು ಅವರನ್ನು ಈ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಕರ್ನಾಟಕ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಅಕಾಡೆಮಿಯ ಎಲ್ಲ ಪದಾಧಿಕಾರಿಗಳು ಸಿಬ್ಬಂದಿ ಹಾಗೂ ನೆರೆದ ವಿದ್ಯಾರ್ಥಿಗಳ ಪರವಾಗಿ ಹೃತ್ಪೂರ್ವಕ ಸ್ವಾಗತವನ್ನು ಬಯಸ್ತಾ ಇದ್ದೀನಿ. ಅವರ ಬಗ್ಗೆ ಕಿರು ಪರಿಚಯವನ್ನು ನೀಡುವುದಾದರೆ ಪ್ರಸ್ತುತ ಅವರು ಬೇಸ್ ಎಜುಕೇಷನಲ್ ಸರ್ವಿಸಸ್ ಎನ್ನುವ ಖಾಸಗಿ ಸಂಸ್ಥೆಯಲ್ಲಿ ತಮ್ಮ ಶೈಕ್ಷಣಿಕ ಸೇವೆಯನ್ನು ನೀಡ್ತಾ ಇದ್ದಾರೆ ಶಿಕ್ಷಕರಾಗಿ. ಅದು ಅಲ್ಲದೆ ಅವರಿಗೆ 13 ವರ್ಷಗಳ ಟೀಚಿಂಗ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಇದ್ದು MSc-ಯನ್ನು 2010ರಲ್ಲಿ ಅವರು ಪಡೆದುಕೊಂಡಿದ್ದಾರೆ. ಅದು ಅಲ್ಲದೆ ಈ MSc-ಯ ಪ್ರಾಜೆಕ್ಟಿಗೆ ಅವರು ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಆಫ್ ಅಟಾಮಿಕ್ ಎನರ್ಜಿ ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಆ್ಯಂಡ್ ಫಿಸಿಕ್ಸ್ ಸಿಂಪೋಸಿಯಂ ಇದರಲ್ಲಿ ಅವಾರ್ಡನ್ನು ಪಡೆದಿರ್ತಾರೆ ಅವರು. ಅದು ಅಲ್ಲದೆ ಸಮ್ಮರ್ ರಿಸರ್ಚ್ ಫೆಲೋಶಿಪ್ ಫ್ರಮ್ ಬಾಬಾ ಅಟಾಮಿಕ್ ರಿಸರ್ಚ್ ಸೆಂಟರ್ ಮುಂಬೈ ಇಲ್ಲಿಂದನೂ ಅವರು ರಿಸರ್ಚ್ ಫೆಲೋಶಿಪ್ಪನ್ನು ಪಡೆದು ಆ ರಿಸರ್ಚನ್ನು ಅವರು ಪೂರ್ಣಗೊಳಿಸಿದ್ದಾರೆ. ತದನಂತರ CET, NEET, JEE, KVPY ಮುಂತಾದ ಪರೀಕ್ಷೆಗಳಿಗೆ ವಿದ್ಯಾರ್ಥಿಗಳನ್ನು ಅವರು ತಯಾರು ಮಾಡ್ತಾರೆ. ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಅವರು ತರಬೇತಿಯನ್ನು ನೀಡುತ್ತಾರೆ. ವಿಷನ್ ಆಫ್ ಟೀಚಿಂಗ್ ಈಸ್ ಟು ರಿಲೇಟ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಆಫ್ ಕ್ಲಾಸ್ ರೂಮ್ with the day-to-day life activities with appropriate examples. This is what Mr. Sandeep Kumar Satrasala's short resume, which I present you to the platform. So welcome you, sir, and I'll
Namaste, sir.
hand over the stage to you. Thank you very much, sir.
Yes, sir. Yes. Thank you, sir. Thank you. Yeah. Yes, dear students, today we will just take up a brief concepts related to the work. Okay. Concept. So mainly we will be concentrating this, to the board level and as well as to your competitive exams ಬಗ್ಗೆನೇ ತಿಳ್ಕೊಳ್ಳೋಣ. ಈಗ ನಾರ್ಮಲ್ ಆಗಿ ವರ್ಕ್ ಅಂದ್ರೆ ಫಿಸಿಕ್ಸ್ ಅಲ್ಲಿ ಒಂದು ಬೇರೆ ಮೀನಿಂಗ್ ಇರುತ್ತೆ. ಓಕೆ, ಅಂಡ್ ಆಸ್ ವೆಲ್ ಆಸ್ ನಿಮ್ದು ಡೇ ಟು ಡೇ ಲೈಫ್ ಅಲ್ಲಿ ವರ್ಕ್ ಅಂದ್ರೆ ಒಂದು ಬೇರೆ ಎಕ್ಸಾಂಪಲ್ ಇರುತ್ತೆ. ಈಗ ಎಕ್ಸಾಂಪಲ್ ನಾವು ನೋಡಿದ್ರೆ ಓಕೆ ಏನಪ್ಪಾ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಒಂದು ಓಕೆ ವಿಲ್ ಆಸ್ ಸಮ್ ಸೆಕ್ಯೂರಿಟಿ ಗಾರ್ಡ್, ಯುವರ್ ಡ್ಯೂಟಿ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಟು ಸ್ಟ್ಯಾಂಡ್ 24 hours ಹಿಯರ್ ಇನ್ ಫ್ರಂಟ್ ಆಫ್ ದ ಗೇಟ್ ಅಂತ. ಅವ್ರ ಪಾಪ ನೀವು ಕೊಟ್ಟಿರೋ ಕೆಲಸ ಅಂದ್ರೆ ವರ್ಕ್ ಹಿ ಹ್ಯಾಸ್ ಡನ್ ಇಟ್, ಬಟ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ಫಿಸಿಕ್ಸ್ ನೀವು ಕೇಳಿದ್ರೆ ಏನಿಲ್ಲ ಅಲ್ವಾ ವರ್ಕ್ ಅಂತ ಕೇಳ್ತಾರೆ. ಇಫ್ ಐ ಟೇಕ್ ಒನ್ ಓಕೆ ಥ್ರೆಡ್ ಅಂಡ್ ಇಫ್ ಐ ಪುಟ್ ಸಮ್ ಬಾಲ್ ಅಂಡ್ ಇಫ್ ಐ ಕೀಪ್ ಆನ್ ರೊಟೇಟಿಂಗ್, ಏನ್ ಮಾಡ್ತಾ ಇದ್ರೆ ಏನ್ ಕೆಲಸ ಮಾಡ್ತಾ ಅಂದ್ರೆ ಐ ಆಮ್ ಡೂಯಿಂಗ್ ಸಮ್ ವರ್ಕ್ ಹಿಯರ್. ಏನದು? ಐ ಆಮ್ ಪ್ಲೇಯಿಂಗ್ ವಾಟ್ ಎವರ್ ಇಟ್. ಬಟ್ ಫಿಸಿಕ್ಸ್ ಪ್ರಕಾರ ನೋಡಿದ್ರೆ ಏನು ಕೆಲಸ ಮಾಡಿಲ್ಲ ಅಂತ ಬರುತ್ತೆ. ಈಗ ಏನಾದ್ರೂ ಸಮ್ ವಾಲ್ ಇದೆಪ್ಪ ಇಲ್ಲಿ, ನಾನು ಬೆಳಗ್ಗೆಯಿಂದ ಮಧ್ಯಾಹ್ನ ತನಕ ಈ ವಾಲ್ನ ಪುಷ್ ಮಾಡ್ತಾನೇ ಇದ್ದೀನಿ ಅಂತ, ಅದು ನನ್ನ ಕೆಲಸ. ಇಮ್ಯಾಜಿನ್ ದಟ್ ಈಸ್ ಮೈ ವರ್ಕ್. ಜನರಲ್ ಇಂಗ್ಲಿಷ್ ಮೀನಿಂಗ್ ಅಲ್ಲಿ ವರ್ಕ್ ಮಾಡಿದ್ದೀನಿ ಅಂತಾನೆ ಬರುತ್ತೆ, ಬಟ್ ಫಿಸಿಕ್ಸ್ ಅಲ್ಲಿ ಏನು ಮಾಡಿಲ್ಲ ಅಂತಾನೆ ಬರುತ್ತೆ. ಈ ಡಿಫ್ರೆನ್ಸ್ ಯಾಕೆ ಅನ್ನೋದು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ಅಂದ್ರೆ ಫಸ್ಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಅಬೌಟ್ ವಾಟ್ ಈಸ್ ದ ಡೆಫಿನೇಷನ್ ಫಾರ್ ದ ವರ್ಕ್. ಓಕೆ, ಸೊ ಅಕಾರ್ಡಿಂಗ್ ಟು ಫಿಸಿಕ್ಸ್, ವರ್ಕ್ ಈಸ್ ಸೆಟ್ ಟು ಬಿ ಡನ್. Work is said to be done if there is a component of displacement in the direction of force. In the direction of force. ಈಗ ಎಕ್ಸಾಂಪಲ್ ನಾನು ತೋರಿಸ್ತೀನಿ. ಇಮ್ಯಾಜಿನ್ ಓಕೆ ಐ ಹ್ಯಾವ್ ಟೇಕನ್ ಎ ಬಾಡಿ ಹಿಯರ್. ನೌ ಐ ಹ್ಯಾವ್ ಮೂವ್ಡ್ ದ ಬಾಡಿ ಫ್ರಮ್ ಹಿಯರ್ ಟು ಹಿಯರ್. ಹೆಂಗಪ್ಪ ಮೂವ್ ಮಾಡಿದ್ರು? ಐ ಹ್ಯಾವ್ ಅಪ್ಲೈಡ್ ಸಮ್ ಫೋರ್ಸ್. F is the force I have applied. ಸರಿ, A ಇಂದ B ಗೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದೆ. This is a displacement. Now this angle is equal to theta. ಈಗ how do I know that work is done or not? ನಾನು ಏನ್ ಹೇಳಿದೆ ನಿಮ್ಗೆ? There should be component of displacement in the direction of force. ಅಂದ್ರೆ this is your displacement vector. If I drop a perpendicular here, this angle will be how much? 90 then I can resolve your displacement into two components. Yaudappa a components, if I see, one will be in the direction of what exactly force, that I can write as S cos theta. One more will be in the perpendicular direction, that I can write as S sin theta. ನೀವು ಇನ್ನೊಂದು ಕ್ವಶನ್ ಕೇಳ್ಬೋದು, ಸರ್ ಎರಡು ಕಾಂಪೊನೆಂಟ್ಸ್ ಯಾಕೆ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಅಂತ. Because I am trying to derive a rectangular components. So two possible rectangular components which I have taken. So S cos theta and S sin theta. Sari ಈಗ now which component of the displacements I am interested ಅಂತ ತಗೊಂಡ್ರೆ, very simple. I am interested to take the components of displacement in the direction of the force. In the direction of force ನನ್ನ ಹತ್ರ S cos theta the S sin theta ಇದೆಯಾ? Obviously S cos theta. So that is the reason now I will define the work done as nothing but the product of the force what I have applied, and I am interested in the component of the displacement in the direction of the force. ಸರಿ ಸರ್, ನಾನು ಏನಾದರೂ ಮೂವ್ ಮಾಡಿದ್ದೀನಿ, but there is no displacement in the direction of okay what exactly force ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. ಅಂದ್ರೆ by any chance, sir, this is the direction of what exactly force I have applied. Understanding? But somewhere there is a displacement from A to B. ಆವಾಗ ನೀವು ನೋಡಿದ್ರೆ the displacement and as well as force are perpendicular to each other, then you don't have any component at all. Component ಯಾವುದು ಇಲ್ಲ ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ? There is no work done. So that is the reason one important point ಯಾವಾಗಲೂ ವರ್ಕ್ ಆಗಿದೆಯಾ ಇಲ್ವಾ ಅಂತ ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳೋಕೆ you have to always check, is there any component of displacement or not. ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಎಷ್ಟು ಕಾಂಪೊನೆಂಟ್ ಇದ್ರೂ ನಂಗೆ ಸಂಬಂಧನೇ ಇಲ್ಲ. ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಎಷ್ಟಿದೆ ಅಷ್ಟು ಮಾತ್ರ ಇಂಪಾರ್ಟೆಂಟ್. ದಟ್ ಐ ಹ್ಯಾವ್ ಅಬ್ಸರ್ವ್ಡ್ S cos theta. ದಿಸ್ ಇಸ್ ಸೆಟ್ ಟು ಬಿ ದ ವರ್ಕ್. ಮತ್ತೆ ಫಿಸಿಕ್ಸ್ ಅಲ್ಲಿ ಯಾವಾಗಲೂ 4 ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ಜ್ಞಾಪಕ ಇಟ್ಕೋಬೇಕು. ವಾಟ್ ಆರ್ ದೋಸ್ 4? Whenever I am learning something new, one thing is nothing but what is the definition and what is okay unit, then what is the dimensional formula, and I need to check whether it is scalar or vector. First year alla, even second year, whenever you are learning anything new, make sure that these 4 parameters you are learning, because along with your competitive exams to the board exams, any new terms will come. These 4 are very important. Now let me check the definition I said now. Now let me take the units. What is the units I'm going to get? Okay, there is a force. The force unit is Newton. Displacement unit is meter. Cos theta doesn't have any units. This together, Newton and meter, I can take as what exactly? Joule, which I write in a capital J. So definition ಆಯ್ತು, unit ಆಯ್ತು. Next comes about what exactly? Dimensional formula. So work done. Dimensional formula of the force I can write m power 1, L power 1, T power minus 2. Dimensional formula of displacement I can write L power 1, which I write m power 1, L power 2, T power minus 2. So I could able to write even about its dimensional formula. Next, I have to check whether it is a scalar and vector. If it is a vector, then I have to give a direction also. If it is a scalar, then I need not to worry, because scalars doesn't have any directions here. Now, you can see that force is a vector, displacement is a vector. In between, you are taking a dot product here. Please excuse me, I'm not well. So that's the reason there is some disturbance in the voice. You can take here, that's nothing but a dot product. Because the definition of the dot product ಏನಂತ ಕರೀತಾರೆ ಜನರಲ್ ಆಗಿ ನಾವು dot product no sir, I can write A dot B is equal to magnitude of A into magnitude of B into cos theta ಅಂತ ತಗೊಳ್ತೀವಿ. So I have taken here magnitude of A, that is nothing but the first vector, second vector, and as well as angle between them. That is important. Now I could able to do this much. This is going to be the vector concept. So which product you have taken here? Dot product. Dot product is also known as a scalar product. So that's the reason. So for sure, it is going to be a scalar. Like this, if you learn these 4 important points, even for your board exam and competitive exams, this will be useful. So please do remember, these 4 points are very, very, very important. Okay. Next, going ahead, what kind of the numericals I can expect this based on this simple concept in the competitive exams? Another, we will check it now. Student mic access area, sir, whether they can speak also or whether they can chat.
Yes, sir. If they raise their hand, I can unmute them and they
Very
can
good,
speak.
very good, very good. Yes, yes, yes. Okay. Now, students, now, if I say there is a force of somewhere about 20 Newton and there is a displacement here, okay, which is equal to some 10 meters and there is an angle of 30 degrees. Now, there is a force of 20 Newton. Imagine now there is a displacement of 10 meters and angle is equal to 30 degrees. Okay. Now I have a 2 cases here. Case number 1, case number 2. Now students, can anyone of you tell me what is the angle I'm supposed to take in case 1? What is the angle I'm supposed to take in case 2? Anybody is going to answer to me now? Someone can answer. Can you raise a hand? Okay. Here, one important point you should know it. So, what is that? Angle between a vectors, how I have to find. That's important. Otherwise, blindly we'll take some 30 degrees and if we substitute the formula, we will not get. Angle between a vectors. Every vector will have tail and as well as a head. So, starting point is tail, ending point is head. Now I have written for force vector tail and head here, displacement vector tail and head here. Same way, force vector tail and head. For you not to get confused, I am taking yellow chalk piece for the displacement. This is tail and head. Now students, observe here carefully. Angle between a vectors you need to consider either between the two tails or between their heads. Both of them actually gives the same answer, but not between tail and head. Now if I observe in the first case, the displacement vector tail and as well as force vector tail, both of them are joined. There only you are measuring angle. That's why, according to this particular concept, I can choose angle theta is equal to 30 degrees. Now very much comfortably, then I can write work done will be equal to magnitude of force, magnitude of displacement into cos theta. What is the magnitude of force I have? 20. What is the magnitude of displacement I have? 10. And what is the angle I have? Cos 30, 20, 10. Cos 30 value will be equal to root 3 by 2. Okay, so 2 ones are 2 fives are, and you will be getting your 100 joules. Everything is taken in SI units. Now, let me take in the second case, what is the angle between them? Sir, they've shown one vector is for force, one vector is for displacement. I have 30 degrees now. Can I consider the same way? No. That is what competitive exams, okay, reading the question and looking at the diagram is very, very important. So we might be knowing this one, okay, but we will be always under the tension or we wanted to manage the time. We will be so, okay, quick enough to solve it, but that's not the case. How much ever you are quick enough, but you should not forget the basics. So what are the most probable mistakes the students will do here in calculating the angles? So we should know that how to calculate the angle either between a tails or either between a head, but not between a head and tail. Now, in second case, this 30 degrees you are not supposed to consider because it is between a tail and as well as a head. Now what I should do now? This is a vector F I have. Okay, this is a displacement. Students, do remember, I can always shift a vector, understanding in this direction. Yes, like this, I can shift a vector. Now, this is going to be the displacement vector. This will become the tail. This will become the head. This angle they have given as 30, but I'm interested this angle. This angle will be equal to how much I will get? 180 minus 30. I will get as what exactly? 150. Now you can calculate the work done. Work done is equal to magnitude of force into magnitude of displacement into again cos theta. So what is the force I have here? So force, how much I have? That is how much I have given? 20. Displacement is how much I have given? 10 into, you have to substitute cos 150 value and simplify whatever it will come. That should be your answer. So this is a okay kind of the problems you can expect. Okay, a simple concept of questions. Any doubts in this? So your active participation is very important, students, because for your benefit only, the organizers are taking a lot of efforts and they're making it. So you have to utilize it. I could see some red marks there, sir. Is that they're raising the hands or what it is?
As of now, no answer.
No, but there is a red mark next to their names. This one.
No, that is because that will be there. That is like some people have joined using the mobile and some people
Okay,
using
okay,
headphone.
fine,
That's
fine.
why the red mark.
Okay, 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 fine, sir. Thank you, thank you. Yes, students, fine. Now, and one more important point here. What is a work done if I say it's actually meaningless? Whenever you say work done, by what force is very, very important. How great it is important, or is it making any sense that I will take up? I will take up only one situation, okay, one problem, and I will take up various situations within this, okay, to understand you that statement. Okay, when I'm calculating the work done, if I simply ask what is the work done, it makes no sense. Because of the one situation, there will be multiple forces will be present. Because of the each force, work done will be different. That point you have to appreciate at end of this particular, okay, 4 or 5 numericals. So observe carefully. Okay. So imagine now the situation is like this. There is a one box. Okay. This box mass is equal to some 2 kgs. I'm displacing the box, understanding, from the position A to the position B. So imagine how I'm displacing by applying some 20 Newton force, which is subtending an angle of 30 degrees. Maybe if I could say about the displacement, how much it has made, some 10 meters. This is my situation. So try to understand. 20 Newton force is being displaced. Sorry, 20 Newton force is used, okay, to displace the box from position A to B by making an angle of 30 degrees. ಆಯ್ತಾ ಇಲ್ಲಿ ಏನ್ ಕೇಳಿದ್ರು ನಮ್ನು ಕರೆಕ್ಟಾ ಫಸ್ಟ್ ಒನ್ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್ ಇಟ್ ಇಸ್ ವಾಟ್ ಈಸ್ ದ ವರ್ಕ್ ಡನ್ ವಾಟ್ ಈಸ್ ದ ವರ್ಕ್ ಡನ್ ಬೈ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ ಈಗ ಕ್ವಶನ್ ಬಹಳ ಸಿಂಪಲ್ ಡೈರೆಕ್ಟ್ ಆಗಿದೆ ಏನದು ದಿಸ್ ಈಸ್ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ನೌ ಯು ಹ್ಯಾವ್ ಟೇಕನ್ ಅ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದೆ ಎಷ್ಟು ಆಂಗಲ್ ಆಗಿದೆ ಅದು 30 ಡಿಗ್ರೀಸ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಎಷ್ಟಿದೆ 10 meters. I have moved from where to where? A to B. Then what is the work done? Work done is equal to what I can take about magnitude of force, magnitude of displacement into cos of angle between them. How much is the magnitude of force I have applied? 20. Displacement is 10 into cos 30, which is nothing but root 3 by 2. Okay, so happily you can get how much it will be exactly 100 root 3 joules. Joules anta, how do you can say it? I can tell clearly because I have taken force also in SI units, displacement also in SI units. That's the reason I can take it is nothing but what exactly the joules. If everything is in SI units. ಇಲ್ಲ ಸರ್ ನಂಗೆ ಇಲ್ಲಿ ಏನಾದರೂ CGS units ಕೊಟ್ರು ಇಲ್ಲಿ SI units ಕೊಟ್ರು ಅಂದ್ರೆ you have to convert everything into SI units, then only you can take that as what exactly joules. And one more point, please note in the previous, okay, just 5 minutes before when we discussed the units, I told only SI unit as joules, but in case if it's CGS units, there will be erg as a CGS units. Conversion is 10 power 7. Ergs is nothing but 1 joule. Okay. Yes. ಇದೇ ಸಿಚುಯೇಷನ್ ಅಲ್ಲಿ if I ask what is the work done by weight ಅಂತ ಕೇಳಿದ್ದೀನಿ. What is the work done by what exactly? Weight. ಸರ್ weight ಇಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆಯಾ? ಅಫ್ಕೋರ್ಸ್ weight ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ. ಕರೆಕ್ಟಾ? ಹೆಂಗ್ ಮಾಡ್ತೀರಾ? ಸರ್ this is the block which I have. Now the block has been displaced here from the situation A to the situation B. How much is the displacement I have made? Exactly 10 meters. This is the direction of what? Displacement. But the weight is acting in which direction? So let me take the yellow color here. The weight acts in this direction. This is going to be force for me. This is going to be the displacement. ನೋಡಿ, first case, second case, same problem ತಗೊಳ್ತಾ ಇದೀನಿ. In the first case, I asked what is the work done by the applied force. But in the second case, I asked what is the work done by the weight. And you can see here, the force and displacements are, what is angle between them? Exactly 90 degrees. Now again, you can write work done due to weight will be equal to magnitude of the force into magnitude of the displacement into cos theta. How much is the magnitude of force? Which force you are interested in, the 20 Newton? No, I am interested in the weight. Weight into displacement into cos 90. When I say cos 90, the work done has to be how much? 0. ನಾನು ಇದೇ ಕೇಳಿದ್ದು. ನಾನು ಬರೀ diagram ಮಾತ್ರ ಕೊಟ್ಟು what is the work done ಅಂದ್ರೆ it makes no sense. You have to ask, there are multiple forces are acting in this problem. Which work done you are speaking? Are you speaking about force? Are you speaking about weight? Are you speaking about normal reaction? Are you speaking about, okay, friction? Are you speaking about net force? I don't know. So you have to specify. ಸರ್ ಮತ್ತೆ ಇದೇ ಕ್ವಶನ್ ಎಕ್ಸಾಮಿನಲ್ಲಿ ಕೇಳಿದ್ರು ಏನು ಕೇಳಿಲ್ಲ ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು? ಬೈ ಡಿಫಾಲ್ಟ್ ಒಂದು ಜ್ಞಾಪಕ ಇಟ್ಕೋಬೇಕು. ಏನಂತ? ಯಾವ ಫೋರ್ಸ್ ಕೇಳಿಲ್ಲ ಅಂದ್ರೆ ಎಕ್ಸಾಮಿನರ್ ಇಸ್ ಆಸ್ಕಿಂಗ್ ಫಾರ್ ಯು ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ನೆಟ್ ಫೋರ್ಸ್. ನೆಟ್ ಫೋರ್ಸ್ ಅಂದ್ರೆ ಏನು? ನೆಟ್ ವರ್ಕ್ ಡನ್ ಅಂದ್ರೆ ಏನು? ವರ್ಕ್ ಡನ್ ಬೈ ಆಲ್ ಫೋರ್ಸಸ್ ತಗೊಳ್ಳಿ, ಆಡ್ ಮಾಡಿ, subtract ಮಾಡಿ along with the signs, and whatever you get, that will be the story. Okay. Yes. Now let me take a third one. ಸೊ ನೀವೇನು 4 ಫೋರ್ಸ್ ಹೇಳಿದಾರಲ್ವಾ ಸರ್, ನೀವು ಬರೀ ತೋರಿಸಿದ್ರೆ 2ನ? ಅಫ್ಕೋರ್ಸ್ ಇನ್ನೊಂದು 2 ಮಾಡೋಣ. ಕೇರ್ಫುಲ್ ಆಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. So if I ask now third one, what is the work done by normal reaction? Correct? Now same story again. This is the body which I have. Okay. Now this is a force. If I take this is F, this angle is equal to how much I have? 30. Now what are the forces I have? One will be weight and one more will be normal reaction. ಇಲ್ಲಿ ಮಕ್ಕಳು ಒಂದು ಬೈಹಾರ್ಟ್ ಮಾಡ್ಕೊಂಡಿರ್ತಾರ, ಇಲ್ಲ ಕಾನ್ಸೆಪ್ಚುಯಲ್ ಕ್ಲಾರಿಟಿ ಒಂದು ಇಟ್ಕೋಬೇಕು. ಸರ್ ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ಮೇಲೆ ಹೋಗ್ತಾ ಇದೆ, ವೆಯ್ಟ್ ಕೆಳಗಡೆ ಆಗ್ತಾ ಇದೆ, ಸೊ ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ವೆಯ್ಟ್ ಅಂತ ಅನ್ಕೊಳ್ತಾರಮ್ಮ. ದಟ್ ಈಸ್ ರಾಂಗ್. ಆಲ್ವೇಸ್ ಯು ನೀಡ್ ಟು ಬ್ಯಾಲೆನ್ಸ್ ಆಲ್ ದ ವೆಕ್ಟರ್ಸ್, ದೆನ್ ಓನ್ಲಿ ಯು ಕ್ಯಾನ್ ಈಕ್ವೇಟ್. ವೆಯ್ಟ್ ಯಾವಾಗ್ಲೂ ನಿಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ. ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ವಿಲ್ ಬಿ ಚೇಂಜಿಂಗ್ ಫ್ರಮ್ ಸಿಚುಯೇಷನ್ ಟು ಸಿಚುಯೇಷನ್. ಸೊ ಈಗ ಏನ್ ಮಾಡ್ತೀನಿ? Let me resolve the vectors. E directionally one vector barate. This will become f cos 30. Next, E directionally I will get one more vector. This will become f sin 30. Okay. Now, body has to move along the plane. ಅಂದ್ರೆ ಬಾಡಿ ಹ್ಯಾಸ್ ಟು ಮೂವ್ ಅಲಾಂಗ್ ದ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಮತ್ತೆ ಸರ್ y ಕಾಂಪೊನೆಂಟ್ಸ್ ಹ್ಯಾಸ್ ಟು ಕ್ಯಾನ್ಸಲ್. ಯಾಕೆ? ಬಾಡಿ ಆಲ್ವೇಸ್ ಹ್ಯಾಸ್ ಟು ಮೂವ್ ಅಲಾಂಗ್ ದ ರಿಸಲ್ಟೆಂಟ್ ಡೈರೆಕ್ಷನ್. ನೀವೇ ಹೇಳಿದ್ರಲ್ವಾ ಸರ್ ಬಾಡಿ ಹ್ಯಾಸ್ ಟು ಮೂವ್ ಅಲಾಂಗ್ ದ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್. ಹೌದು. ಮತ್ತೆ y ಆಕ್ಸಿಸ್ ಅಲ್ಲಿ ಏನು ಫೋರ್ಸ್ ಇಲ್ವಾ? ಇದೆ. ನೆಟ್ ಫೋರ್ಸ್ ಇಲ್ಲ. ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ? ಮೇಲೆ ಫೋರ್ಸಸ್ ಸಮ್ಮೇಶನ್, ಕೆಳಗಡೆ ಫೋರ್ಸಸ್ ಸಮ್ಮೇಶನ್ಗೂ ಬ್ಯಾಲೆನ್ಸ್ ಆಗ್ಬೇಕು. ದಟ್ಸ್ ಅ ಕಾನ್ಸೆಪ್ಟ್. Now let me check. What are the upward forces I have here? F sin 30 plus normal reaction should be balanced with weight. What is the F I have taken already? 20 into sin 30 value will become 1 by 2 plus normal reaction. Weight of the body is equal to how much? M into G. M value is equal to 2, G value is equal to 10. How much you get here? 10 plus N is equal to how much I got? 20. So from this I'd have got normal reaction is equal to how much I will get? Exactly 10. So now I computed only normal reaction. Iga the direction of normal reaction is perpendicularly upward. The displacement of the body is in this direction. This is the direction of the body because you said the body is moving from A to B horizontally. Ill nodaya, est angle is again 90. Now if I ask what is the work done will be equal to normal reaction into displacement into cos 90. So cos 90 is equal to 0. ಕರೆಕ್ಟಾ? ಇದು ಕಾನ್ಸೆಪ್ಟ್ಸ್. ಇದೇ ಕ್ವಶನ್ ಎಕ್ಸಾಮಿನೇಷನ್ ಅಲ್ಲಿ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ ನಲ್ಲಿ ಬಂತು ಅಂದ್ರೆ ನೀವು ಇದೆಲ್ಲ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ನಿಮ್ಗೆ ಕಾಮನ್ ಸೆನ್ಸ್ ಒಂದು ಗೊತ್ತಾಗತ್ತೆ. ಏನಂತ ಅರ್ಥ? ಸರ್ ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ವ್ಯಾಲ್ಯೂ ನನ್ಗೆ ಗೊತ್ತೇ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಯಾಕಪ್ಪ? ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ಎಷ್ಟು ವ್ಯಾಲ್ಯೂ ಇದ್ರೂ ಇದು ಮೇಲೇನೆ ಇರುತ್ತೆ. ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಆಲ್ವೇಸ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ದ ಪ್ಲೇನ್ ಕಂಟೈನಿಂಗ್. ಯು ಆರ್ ಆಸ್ಕಿಂಗ್ ದ ಬಾಡಿ ಟು ಡಿಸ್ಪ್ಲೇಸ್ ಅಲಾಂಗ್ ದ ಹಾರಿಜಾಂಟಲಿ. ಆವಾಗ ಈ ಆಂಗಲ್ 90 ಇರೋ ಟೈಮಲ್ಲಿ ಕಾಸ್ 90 ವಿಲ್ ಬಿ 0. ನಂಗೆ ಎಷ್ಟು ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಇದ್ರೂ ನಂಗೆ ಏನು ಬೇಕಾಗಿಲ್ಲ. ದೆನ್ ಆನ್ಸರ್ ಹ್ಯಾಸ್ ಟು ಬಿ 0 ಓನ್ಲಿ. ದಟ್ಸ್ ಅ ಸಿಂಪಲ್ ಲಾಜಿಕ್. ಎಸ್ ಆರ್ ನೋ? ನೋ ಇದೇ ಕ್ವಶನ್ ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ವೇರಿಯೇಷನ್ ಅಲ್ಲಿ ತಗೊಳ್ಳೋಣ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದ ಫ್ರಿಕ್ಷನ್. ಸೊ ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ಎಷ್ಟು ಬಂತು ನಮಗೂ? 10. ದಟ್ ವಿ ವಿಲ್ ಯೂಸ್ ಇಟ್ ಎನಿವೇ. ಇಮ್ಯಾಜಿನ್ if the surface is rough, because so far ಅವ್ರು ಏನು ಕೊಡ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಇಟ್ಸ್ ಅ ಸ್ಮೂತ್ ಸರ್ಫೇಸ್, there is no friction. ಈಗ ನಾನು ಸರ್ಫೇಸ್ ರಫ್ ಆಗಿ ತಗೊಂಡಿದ್ದೀನಿ. if the surface is rough, the coefficient of friction is equal to 0.5. then what is the work done by the frictional force? ಕರೆಕ್ಟಾ? ವೆರಿ ಗುಡ್. ಫಸ್ಟ್ ನಾನು ಏನ್ ಮಾಡ್ಬೇಕು? ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಎಷ್ಟು ಅಂತ ಕಂಡಿಡ್ಬೇಕು. ಕರೆಕ್ಟಾ? ನೋಡಪ್ಪ, ನೀವು ಯಾವ ಫ್ರೇಮ್ ಅಲ್ಲಿ ಇದ್ರೂ, ಯಾವ ಲೆವೆಲ್ ಅಲ್ಲಿ ಇದ್ರೂ, ಆರ್ ಇದೇರ್ ಇನ್ ಹಾರಿಜಾಂಟಲ್ ಫ್ರೇಮ್, ಆರ್ ಇದೇರ್ ಇನ್ ಇನ್ಕ್ಲೈನ್ಡ್ ಪ್ಲೇನ್, ವೇರ್ ಎವರ್ ಇಟ್ ಈಸ್, the definition of the friction is the maximum friction value should be equal to how much it is? Mu into n. First, this is nothing but the limiting friction. What is the value of mu I have? 0.5. What is the value of the limiting friction I have? N. N value is equal to how much? Just now I have computed 10. 10 by 2 will be equal to 5 joules. ನಿಮ್ಗೂ ಫ್ರಿಕ್ಷನ್ ಹೇಳಿಕೊಡೋ ಟೈಮಲ್ಲಿ ಟೀಚರ್ ಹೇಳಿಟ್ಕೊಡ್ತಾರೆ. ಏನಯ್ಯ ಫ್ರಿಕ್ಷನ್ ಯಾವಾಗ್ಲೂ 5? ಇಲ್ಲ, ಫ್ರಿಕ್ಷನ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ 5. ದಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಎ ಲಿಮಿಟಿಂಗ್ ಫ್ರಿಕ್ಷನ್. ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ? ಇಟ್ ಕೆನ್ ಟೇಕ್ ಎನಿ ವ್ಯಾಲ್ಯೂ ಬಿಟ್ವೀನ್ 0 ಅಂಡ್ 5. ಯಾವ ವ್ಯಾಲ್ಯೂ ತಗೊಳತ್ತೆ? ದಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಯುವರ್ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್. ಅಂದ್ರೆ ಏನು? ಇಲ್ಲಿ ನೋಡಿ, you have applied, this is the direction of the force, this angle is how much? Theta. Now I will take here is f cos theta, then I will take here F sine theta. Then I will take here normal reaction. This is weight. This is friction. Correct? Now, perpendicular directionally body anyway move agalla because just now I could able to calculate. ನಮ್ಗಿರೋ ಪಾಸಿಬಿಲಿಟಿ ಏನು ದ ಬಾಡಿ ಹ್ಯಾಸ್ ಟು ಮೂವ್ ಅಲಾಂಗ್ ದ ಹಾರಿಜಾಂಟಲಿ. ಮತ್ತೆ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಜಾಸ್ತಿ ಆಯ್ತು ಅಂದ್ರೆ ಸರ್ ಲೆಫ್ಟ್ ಅಲ್ಲಿ ಹೋಗುತ್ತೆ, ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಕಡಿಮೆ ಆಯ್ತು ಅಂದ್ರೆ ದೆನ್ ಇಟ್ ವಿಲ್ ಮೂವ್ ಇನ್ ಎಫ್ ಕಾಸ್ ಥೀಟಾ ಅಂತ ಹೇಳ್ಬಾರ್ದು. ಯಾಕಪ್ಪ? ದ ಡ್ಯೂಟಿ ಆಫ್ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಏನು? ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಆಲ್ವೇಸ್ ಹ್ಯಾಸ್ ಟು ಅರೆಸ್ಟ್ ದ ಮೋಷನ್. ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ? ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಕಡೆ ಬಾಡಿ ಬರಲ್ಲ. ನಿಮ್ಗೆ ಎಫ್ ಕಾಸ್ ಥೀಟಾ ಜಾಸ್ತಿ ಆಯ್ತಾ, then the body will move. Okay, how? Because you have to calculate this f cos theta value and you have to compare with this frictional force value. ಹೇಳ್ತೀನಿ ನೋಡಿ. ಈಗ f cos theta ಎಷ್ಟಿದೆ ತಗೊಳ್ಳಿ. ಸರ್ f sin theta ಯಾಕೆ ತಗೊಳ್ತಾ ಇಲ್ಲ? ಐ ಆಮ್ ನಾಟ್ ಇಂಟ್ರೆಸ್ಟೆಡ್ because I am interested in what exactly the displacement of a body that is from A to B. Then starting definition much I am sticking. What is meaning of the work? Work is nothing but, okay, if the body has a displacement in the direction of the force, I always have to concentrate the component of force in the direction of the displacement. Vice versa anyway. ಈಗ F cos theta value ಎಷ್ಟಿದೆ? 20. Cos theta is equal to right root 10 root 3 10 into 1.732 ನಾನು 1.7 ತಗೊಳ್ಳೋಣ. How much I will get? 17. ಅಂದ್ರೆ ಈ ಕಡೆ ಇರೋದು 5 ಅಪ್ಪ, ಈ ಕಡೆ ಇರೋದು 17. ದಟ್ ಮೀನ್ಸ್ ಐ ಕ್ಲಿಯರ್ಲಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಟ್ ಎಫ್ ಕಾಸ್ ಥೀಟಾ ಇಸ್ ಗ್ರೇಟರ್, ದಟ್ಸ್ ವೈ ಬಾಡಿ ವಿಲ್ ಡಿಸ್ಪ್ಲೇಸ್. ಸರ್ ಬೈ ಎನಿ ಚಾನ್ಸ್ ನೀವು ಯಾವ್ದೋ ನಂಬರ್ ತಗೊಂಡಿದ್ರ, ಇನ್ ಕೇಸ್ ಇಲ್ಲಿ 4 ಅಂತ ಬಂತು ಅಂತ ಅನ್ಕೊಳ್ಳಿ, ಆವಾಗ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಎಷ್ಟು? 5. ಬಟ್ ಇಲ್ಲಿ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ ಎಷ್ಟು? 4. ಆವಾಗ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ವಿಲ್ ಅಡ್ಜಸ್ಟ್ ಸಚ್ ದಟ್ ದಿಸ್ ಆಲ್ಸೋ ವಿಲ್ ಬಿ 4, ನೆಟ್ ಫೋರ್ಸ್ ವಿಲ್ ಬ್ಯಾಲೆನ್ಸ್. ಇಲ್ಲ ಸರ್ ನಾನು ಇಲ್ಲಿ 3 ತಗೊಳ್ತೀನಿ, 3 ಬಂತು ನನ್ಗೆ, ಆವಾಗ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಆಲ್ಸೋ ವಿಲ್ ಅಡ್ಜಸ್ಟ್ ಆಸ್ ಅ 3. ಯಾಕೆ? ಬಿಕಾಸ್ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ವ್ಯಾಲ್ಯೂ ಈಸ್ ಆಲ್ವೇಸ್ ಲೈಸ್ ಬಿಟ್ವೀನ್ 0 ಅಂಡ್ ಆಸ್ ವೆಲ್ ಆಸ್ ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ಫ್ರಿಕ್ಷನ್. ನನ್ 0 ಇಂದ 5 ಅಂಕ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇರುತ್ತೆ, ಆ ಯಾವ ವ್ಯಾಲ್ಯೂ ತಗೋಬೇಕು ಅಂದ್ರೆ ನಂಗೆ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ ಮೇಲೆ ಬರುತ್ತೆ. ನಾನು 5 ತಗೊಂಡಿದ್ದೀನಿ ಸರ್, ಇಲ್ಲಿ 5 ಆಲ್ರೆಡಿ ಬಂದಿದೆ ಮ್ಯಾಚಿಂಗ್, ಇಲ್ಲಿ 6 ಬಂತು, ಬಟ್ ಇದಕ್ಕೆ 5 ಮೇಲೆ ಬರಕ್ ಆಗಲ್ಲ ಬಿಕಾಸ್ ಎಫ್ ಮ್ಯಾಕ್ಸ್ ಇಸ್ 5. ಅವಾಗ ಏನಂತೆ? ಎಫ್ ಕಾಸ್ ಥೀಟಾ ವಿಲ್ ಡಾಮಿನೇಟ್, ಸೊ ಬಾಡಿ ಹ್ಯಾಸ್ ಟು ಮೂವ್. ಅದು ಲಾಜಿಕ್. ಈಗ ಫೈನಲಿ ಐ ಅಂಡರ್ಸ್ಟುಡ್ ದಟ್ ಎಫ್ ಕಾಸ್ ಥೀಟಾ ಈಸ್, ದಟ್ ಮೀನ್ಸ್ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ ಈಸ್ ಗ್ರೇಟರ್ ದನ್ ದ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್. ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ? ಬಾಡಿ ಹ್ಯಾಸ್ ಟು ಮೂವ್ ಇನ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್. ದಟ್ ಮೀನ್ಸ್ ದೇರ್ ಇಸ್ ಅ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಇದೆ, then there is what exactly work done. So let me compute. So this is what exactly now? 17. Okay, fine. ಈಗ ಏನ್ ಕೇಳಿದ್ರಪ್ಪ ನೀವು? work done by which force? I asked frictional force. Come again to the back. What is the work done? Frictional force, magnitude, displacement, magnitude, cos theta. What is the frictional force? ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ 5 ತಗೋಬೇಕಾ? ಹೌದು, ಅದೇ ನನ್ಗೆ ಗೊತ್ತಾಗ್ಬೇಕು. ಹೆಂಗ್ ಗೊತ್ತಾಗ್ಬೇಕು? ಐ ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್. If applied force is less than F max, then obviously I will take that value as a frictional force. But applied force ಏನಿದೆ ನನ್ಗೂ? Greater than frictional force. Then obviously then I have to take what exactly? Frictional force value only. Okay. So frictional force ಎಷ್ಟಿದೆ ನನ್ನ ಹತ್ರ? 5. Displacement ಎಷ್ಟಿದೆ? 10. And I will write as angle between them. Because the body is moving from A to B, that is towards the right, but frictional force acts towards the left. So 5 into 10 will become how much? 50. Cos 180 will become minus 1. Then I will get how much? Minus 50 joules. That's how you need to understand. Sir, then what is the meaning of negative sign? Now, who is doing the work here? Okay, is work is done by the force or work is done against the force? That is very important. Friction is not doing the work. Why? Because friction always opposes the motion. Andre, you are applying an external force to overcome the friction. Whenever work is done by the force, then it will be always positive. whenever work is done against the force, then it will be always negative. Physics ಅಲ್ಲಿ ಯಾವಾಗ್ಲೂ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ, ನೆಗೆಟಿವ್ ಸೈನ್ ಬಂತು ಅಂದ್ರೆ ನೀವೇನೋ ಒಂದು ಇಮ್ಯಾಜಿನೇಷನ್ ಅಲ್ಲಿ ಇಟ್ಕೊಳ್ತೀರಾ ಸ್ಟಾರ್ಟಿಂಗ್ ಆಫ್ ದ ಪ್ರಾಬ್ಲಮ್, ಆ ಇಮ್ಯಾಜಿನೇಷನ್ ತಪ್ಪಾಯ್ತು ಅಂತ ಅರ್ಥ. ನೀವೇನ್ ಕ್ವಶನ್ ಕೇಳಿದ್ರ, ವರ್ಕ್ ಡನ್ ಬೈ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಅಂತ ಅನ್ಕೊಂಡ್ರೆ ನೀವು ಸಾಲ್ವ್ ಮಾಡಿದ್ರ. ಪಾಸಿಟಿವ್ ಸೈನ್ ಬಂತು ಅಂದ್ರೆ ನಿಜವಾಗ್ಲೂ ಫ್ರಿಕ್ಷನ್ ವರ್ಕ್ ಮಾಡಿದೆ ಅಂತ ಅರ್ಥ. ಬಟ್ ಅಲ್ಲಿ ಏನಾಯ್ತು, ನೆಗೆಟಿವ್ ಸೈನ್ ಬಂತು ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ, ಫ್ರಿಕ್ಷನ್ ವರ್ಕ್ ಮಾಡಿಲ್ಲ, ಓಕೆ, ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಮೇಲೆ ವರ್ಕ್ ಆಗಿದೆ. ಸೊ ದ ನೆಗೆಟಿವ್ ಸೈನ್ ಸೇಸ್ ವರ್ಕ್ ಈಸ್ ಡನ್ against the frictional force. That's very very important point. Okay, so physics ಅಲ್ಲಿ ನೆಗೆಟಿವ್ ಸೈನ್ ನೀವು ಮಿಸ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಆಗಲ್ಲ. ಓಕೆ, ನ್ಯೂಮರಿಕಲ್ಸ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ವ್ಯಾಲ್ಯೂಸ್ ಮಿಸ್ ಆಗತ್ತೆ. ಅದಕ್ಕೋಸ್ಕರ ಬೋರ್ಡ್ ಎಕ್ಸಾಮಿನೇಷನ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ಫುಲ್ ಮಾರ್ಕ್ಸ್ ಬೇಕು ನ್ಯೂಮರಿಕಲ್ಸ್ ಅಲ್ಲಿ ಅಂತಂದ್ರೆ ಈ ನೆಗೆಟಿವ್ ಸೈನ್ ಮೀನಿಂಗ್ ಏನು ಅಂತ ಎಲಾಬ್ರೇಟ್ ಮಾಡಬೇಕು. ನಿಮ್ ಸೆಕೆಂಡ್ ಇಯರ್ ಅಲ್ಲಿ ಎಷ್ಟೋ ಕಡೆ ನೆಗೆಟಿವ್ ಸೈನ್ ಬರುತ್ತೆ, ಬಂದ್ಮೇಲೆ ಎವ್ರಿ ಟೈಮ್ ಯು ಹ್ಯಾವ್ ಟು ಆನ್ಸರ್ ವಾಟ್ ಈಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ನೆಗೆಟಿವ್ ಸೈನ್. ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಸೈನ್ ಏನ್ ಮೀನಿಂಗು, ವರ್ಕ್ ಈಸ್ ಡನ್ ಅಗೇನ್ಸ್ಟ್ ದ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್. ಎಷ್ಟು ವರ್ಕ್ ಅಪ್ಪ, 50 ಜೌಲ್ಸ್. ಕರೆಕ್ಟಾ? ವರ್ಕ್ ಡನ್ ಬೈ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಇಸ್ -50, ವರ್ಕ್ ಡನ್ ಅಗೇನ್ಸ್ಟ್ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಇಸ್ +50. ಅದು ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ. ಇದಕ್ಕೆ ಮುಂಚೆ ನಿಂಗೆ ಆಲ್ರೆಡಿ ಬಂದಿರಬಹುದು ಆಕ್ಸಲರೇಷನ್ ರಿಟಾರ್ಡೇಷನ್ ಅಲ್ಲಿ. ಆಕ್ಸಲರೇಷನ್ ಇಸ್ -3. ಏನಾ ಮೈನಸ್ ಸೈನು? That means velocity and acceleration are in opposite in the direction. Velocity is keeps on decreasing. That's why you will tell us that is a negative sign meaning ಅಂತ. ಯಾವಾಗ್ಲೂ ನೆಗೆಟಿವ್ ಸೈನ್ ಬಂತು ಅಂದ್ರೆ ಮಾರ್ಕ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಕೇಳಿ ಟೀಚರ್ಸ್ನು, ಇಲ್ಲ ಸರ್ಚ್ ಮಾಡಿ, ಬಟ್ ಟ್ರೈ ಟು ಲರ್ನ್. ಈಗ ನಾವು ಒನ್ ಮೋರ್ ಟೈಪ್ ಆಫ್ ದ ನ್ಯೂಮರಿಕಲ್ಸ್ ನೋಡಿದ್ರೆ, ನನ್ನ ಲಾಜಿಕ್ ಏನು, ಯಾಕೆ ಇದು ಮೆಥಡ್ ಮಾಡಿದೀನಿ ಅಂದ್ರೆ ಒಂದೇ ಸಿಚುಯೇಷನ್ ಅಲ್ಲಿ ನಾನು 4-5 ಪ್ರಾಬ್ಲಮ್ ಮಾಡ್ಬೋದು. ನಾನು 4 ಮಾಡಿ ತೋರಿಸಿದೀನಿ ನಿಮ್ಗೆ. ಏಕಂತಾರ್ಥ ನಿಂಗೆ ಒಂದೇ ಜ್ಞಾಪಕ ಇಟ್ಕೋಬೇಕು, ವರ್ಕ್ ಡನ್ ಬೈ ಫೋರ್ಸ್ ಅಂದ್ರೆ ಯಾವ ಫೋರ್ಸು ಅನ್ನೋದು ತಗೊಂಡ್ ಬರಬೇಕು, ನೀಟಾಗಿ ಮಾಡಬೇಕು. ಇದು ಬೇಸಿಕ್ ಥಿಂಗ್ಸ್. ಇದೇ ತರ ನಿಮ್ಗೂ ಕೋರ್ಸ್ ಅಲ್ಲಿ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ದ ಕ್ವಶನ್ಸ್ ಅಂಡ್ ಆಲ್ ವಿಲ್ ಬಿ ಕೀಪ್ ಆನ್ ಗೋಯಿಂಗ್ ಇನ್ ದ ಅದರ್ ಲೆವೆಲ್ಸ್ ಆಲ್ಸೋ. Now if I say there is a 2 kilogram object and a force produces an acceleration of 3i cap minus 4j cap plus 8k cap, then this particular force produces a displacement of minus 4j cap plus 3i cap plus 4k cap. Then what is the work done by the force? ಇಲ್ಲಿ ನಿಮ್ಗೆ ಇರೋದು ಒಂದೇ ಫೋರ್ಸ್, ಬೇರೆ ಬೇರೆ ಫೋರ್ಸ್ ಎಲ್ಲ ತಗೊಳಕ್ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಅವ್ರು ಏನ್ ಹೇಳಿದ್ರು, ದರ್ ಇಸ್ ಓನ್ಲಿ ಒನ್ ಫೋರ್ಸ್ ಅಂತ. ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ಎಲ್ಲೋ ಬೇರೆ ಬೇರೆ ಫೋರ್ಸಸ್ ಬರುತ್ತೆ, ಇದರ ಬಗ್ಗೆ ತಲೆ ಕೆಡಿಸ್ಕೋಬೇಡ. Now what I should do, first now let me write the force vector. The force vector is equal to what I can write, mass into acceleration. Mass is given as 2, acceleration is given as 3i cap minus 4j cap plus 8k cap. Correct? So 2 into 3, 6i cap, 2 into 4 minus 8j cap, 2 into 8, 16k cap. Next, what is the displacement? Displacement there themselves have given minus 4j cap plus 3i cap plus 4k cap. ಈಗ ನಾನು ಏನ್ ಮಾಡಬೇಕು, ಫೋರ್ಸ್ ವೆಕ್ಟರ್ ಕೊಟ್ರು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ವೆಕ್ಟರ್ ಕೊಟ್ರು, ಐ ಶುಡ್ ನೋ ದ ಡಾಟ್ ಪ್ರಾಡಕ್ಟ್. ಕರೆಕ್ಟಾ? ಸೊ ಡಾಟ್ ಪ್ರಾಡಕ್ಟ್ ರೂಲ್ಸ್ ಏನು, ಇಫ್ ದ ಫಸ್ಟ್ ವೆಕ್ಟರ್ ಈಸ್ axi cap plus ayj cap plus azk cap. Second vector is b, I can write as bxi cap plus byj cap plus bzk cap. Okay. Now if I write about a dot b is equal to what I should do, the simple rule is a dot b, magnitude of x components, magnitude of y components, magnitude of z components ತಗೊಂಡು add ಮಾಡಿ ಅಷ್ಟೇ, ಇನ್ನೇನಿಲ್ಲ. X components, how much I will get, ax bx plus y components, how much I will get ay by plus z components, how much I'll get az bz. That's a simple rule. ಬಟ್ ಇಲ್ಲಿ ಮಾಡಕ್ ಮುಂಚೆ ಏನ್ ಮಾಡ್ಕೋಬೇಕು ಅಂದ್ರೆ ಎಕ್ಸ್ ಕಾಂಪೊನೆಂಟ್ಸ್ ವೈ ಕಾಂಪೊನೆಂಟ್ಸ್ ಝೆಡ್ ಕಾಂಪೊನೆಂಟ್ಸ್ ಒಂದೇ ಆರ್ಡರ್ ಅಲ್ಲಿ ಬರ್ಕೋಬೇಕು. ಎಷ್ಟು ಸ್ಟೂಡೆಂಟ್ಸ್ ಅದೇ ಮಿಸ್ಟೇಕ್ಸ್ ಮಾಡ್ತಾ ಇರ್ತೀರ. ಏನ್ ಮಿಸ್ಟೇಕ್ ಮಾಡ್ತೀವಿ ಈಗ ಸರ್ ಓಕೆ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಎಕ್ಸ್ ಕಾಂಪೊನೆಂಟ್ಸ್ ಅಂದ್ರೆ 6 × 4 ಅಂತ ತಗೊಳ್ತಾರೆ, ಇಲ್ಲ 6 × -4 ಅಂತ ತಗೊಳ್ತಾರೆ. ಅದು ತಪ್ಪು. ಯಾವಾಗ್ಲೂ ನೀವು ಈ ಪ್ರಾಡಕ್ಟ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಫಸ್ಟ್ ರೂಲ್ ಏನು, ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್ ದ ಗಿವನ್ ವೆಕ್ಟರ್ ಇನ್ ದ ಡೈರೆಕ್ಷನ್ ಲೈಕ್ ಎಕ್ಸ್ ಕಾಂಪೊನೆಂಟ್ಸ್ ಫಸ್ಟ್, ವೈ ಕಾಂಪೊನೆಂಟ್, ಝೆಡ್ ಅಂದ್ರೆ ಈ ಸೀಕ್ವೆನ್ಸ್ ಈ ಆರ್ಡರ್ ಅಲ್ಲಿ ನೀಟಾಗಿ ಮಾಡಬೇಕು ಫಸ್ಟ್. ಮತ್ತೆ ಸರ್ ಇಲ್ಲಿ ಇದೆಯಾ ನೋಡಿ, ಫಸ್ಟ್ ವೆಕ್ಟರ್ ಏನು 6 × i ಈ ಮೈನಸ್ ಸೈನ್ ಒಳಗಡೆ ತಗೊಳ್ಳಿ, ಆವಾಗ -8 × j ಪ್ಲಸ್ 16 × k. ಇದೇ ತರ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ವೆಕ್ಟರ್ನ ಬರಿ ನೋಡೋಣ ಏನ್ ಬರುತ್ತೆ ಈಗ. ಎಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನ್ ಮಾಡ್ಬೇಕಪ್ಪ, ನಾನು ಏನ್ ಹೇಳಿದೀನಿ, ಬಿ ಎಕ್ಸ್ ಐ ಕ್ಯಾಪ್, ಬಿ ವೈ ಜೆ ಕ್ಯಾಪ್, ಬಿ ಝೆಡ್ ಕೆ ಕ್ಯಾಪ್ ಅಂತ ಹೇಳಿದೀನಿ. ಅಂದ್ರೆ ಫಸ್ಟ್ ಯಾವ ಕಾಂಪೊನೆಂಟ್ ಬರೀಬೇಕು, ಎಕ್ಸ್ ಕಾಂಪೊನೆಂಟ್. ಎಕ್ಸ್ ಕಾಂಪೊನೆಂಟ್ ಎಷ್ಟಿದೆ 3. ಓಕೆ 3 ಐ ಕ್ಯಾಪ್ ಅಲ್ವಾ ಇದು, ಸಾರಿ. ನೆಕ್ಸ್ಟ್ ಏನ್ ತಗೋಬೇಕು, ವೈ ಕಾಂಪೊನೆಂಟ್ -4 ಜೆ ಕ್ಯಾಪ್ ಪ್ಲಸ್ 4 ಕೆ ಕ್ಯಾಪ್. ಈಗ this is in the direction of what, force. This is what exactly the displacement. ನಾನು ಪರ್ಫೆಕ್ಟ್ ಆಗಿ ಬರ್ಕೊಂಡೆ. ಈಗ ಏನ್ ಮಾಡ್ಬೋದು, ವರ್ಕ್ ಡನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಡೈರೆಕ್ಟ್ ಸ್ಟೆಪ್. ನನ್ ಮುಂಚೆ ನಿಮ್ಗೂ ಫೋರ್ಸ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಕೊಡ್ತಾ ಇತ್ತು, ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಕೊಡ್ತಾ ಇತ್ತು, ಆಂಗಲ್ ಕೊಡ್ತಾ ಇತ್ತು. ಆವಾಗ ದೆನ್ ಯೂಸ್ ದ ಫಾರ್ಮುಲಾ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಎಫ್ ಇಂಟು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಎಸ್ ಇಂಟು ಕಾಸ್ ಥೀಟಾ. ಅದು ಒನ್ ಮೆಥಡ್ ಆಫ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲಿ ಮಾಡಿದ್ವಿ ನೋಡಿ ಅದು. ಬಟ್ ಇಲ್ಲಿ ಏನ್ ಕೊಡ್ತಾ ಇದ್ದೀನಿ ನಾನು, ಐ ಹ್ಯಾವ್ ಗಿವನ್ ಡೈರೆಕ್ಟ್ಲಿ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ವಾಟ್ ವೆಕ್ಟರ್ಸ್ ಮೆಥಡ್ ಅಲ್ಲಿ. ವೆಕ್ಟರ್ಸ್ ಮೆಥಡ್ ಅಲ್ಲಿ ಇರೋ ಟೈಮಲ್ಲಿ ಯು ಹ್ಯಾವ್ ಟು ಯೂಸ್ ದಿಸ್ ಮೆಥಡ್ ಡೈರೆಕ್ಟ್ಲಿ. ನಾವು ಅಬ್ಸರ್ವ್ ಹಿಯರ್ product ax into bx, x components, how much I will get, 6 × 3. Next y components, how much I will get, -4 into -8. Next, how much I'll get, 16 × 4. How much I'll get, 18 plus 32 plus 64. Simplify, you'll get in terms of your joules or okay, whatever the units they will give, you can able to choose this one. This is a mechanism. ಸೊ ಇಲ್ಲಿ ಮಕ್ಕಳು ಮಾಡೋ ಪ್ರಾಬಬಲ್ ಮಿಸ್ಟೇಕ್ಸ್ ಏನಿದೆ ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಒಂದು, they will not consider 2 kg directly, they will take acceleration itself as like a force. ಇದು ಫಸ್ಟ್ ಮಿಸ್ಟೇಕ್ ಪಾಸಿಬಿಲಿಟಿ. ಸೆಕೆಂಡ್ ಮಿಸ್ಟೇಕ್, they will not write the displacement vector as xyz directly. ಓಕೆ, ನಾನು ಇದೇ ಎಕ್ಸ್ ಕಾಂಪೊನೆಂಟ್ ಅಂತ ತಗೊಳ್ತೀನಿ, ಇದೇ ವೈ ಕಾಂಪೊನೆಂಟ್ ತಗೊಳ್ತೀನಿ, ಇದು ಝಡ್ ಅಂತ ಐ ಆಮ್ ಅಸ್ಯೂಮಿಂಗ್ ಆಸ್ ಇಫ್ ಎಕ್ಸಾಮಿನರ್ ಹ್ಯಾಸ್ ಗಿವೆನ್ ಟು ಮೀ ಅಂತ. ನಾನು ಎಷ್ಟೋ ಸ್ಟೂಡೆಂಟ್ಸ್ ನೋಡಿದ್ದೀನಿ, ನಮ್ಮ ಮಕ್ಕಳು ಸರ್ 180ಗೆ ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಆಯ ಬಂತು, 175, ಒಂದು ಕ್ವಶನ್ ಮಿಸ್ಟೇಕ್ ಆಯ್ತು, ಎಷ್ಟು ಬೇಜಾರಾಗತ್ತೆ. ಯಾವ್ದಾಯ ಸರ್ ನಾನು ಆರ್ಡ್ರಲ್ಲಿ ತಗೊಂಡಾಗಿಲ್ಲ ನೀಟಲ್ಲಿ. ಎಷ್ಟೋ ಜನ ಮಕ್ಕಳು ನಾನು ಹಂಗೆ ತರ ನೋಡಿದ್ದೀನಿ. ಯು ಪ್ಲೀಸ್ ಡೋಂಟ್ ಬಿ ಇನ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಕೇಸ್. ಕರೆಕ್ಟಾ? ಇನ್ನೊಂದು, ಅವ್ರ ಆರ್ಡ್ರಲ್ಲಿ ತಗೊಳ್ತಾರೆ ಪಾಪ, ಈ ನೆಗೆಟಿವ್ ಸೈನ್ಸ್ ಮರ್ತೋಗಿ ಬರ್ತಾರೆ. ಈಗ ಏನ್ ಮಾಡಿದೀನಿ ಸರ್, ಇದು ದಿಸ್ ಇಸ್ 8 ಸರ್, ದಿಸ್ ಇಸ್ 4 ಸರ್, 8 × 4. ಆ ನೆಗೆಟಿವ್ ಸೈನ್ ಒಂದೊಂದ್ಸರಿ ಇಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾರೆ, ಇನ್ನೊಂದ್ಸರಿ ಮಾಡಲ್ಲ. ಆ ತರ ಮಿಸ್ಟೇಕ್ಸ್ ಮಾಡಬಾರ್ದು. ದಟ್ ಶುಡ್ ಬಿ ಒನ್ ಆಫ್ ದ ಪಾಸಿಬಿಲಿಟೀಸ್. ಅಂಡರ್ಸ್ಟುಡ್? ಸೊ ವಿಲ್ ಟೇಕ್ ಅಪ್ one more the type of the question in terms of the vectors, and maybe I think we can wind up this session. Sir, can I get 5 more minutes?
You have 10 more minutes, sir. We can continue.
Okay, very good, sir. Thank you. Thank you. Yes. So, if let us say a force is nothing but 2i cap plus 3j cap plus 4k cap, this is a force. Now it is displacing the particle from the position A 3, 2, -1 to B -1, 3, -4 ಅಂತ ತಗೊಳ್ಳೋಣ. Now what is the work done? Imagine everything they have given is in SI units. What is the work done? First ನಾನು ಏನು ಮಾಡ್ತೀನಿ? Force they have given. Now I need to get the displacement. ಅಂದ್ರೆ now if I have written the displacement andre, imagine this is going to be my coordinate axis system. This could be the particle A, and now this could be the position B. So A ಇಂದ B ಗೆ ಹೋಗಿದ ಬಾಡಿ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. Now I have to tell about the displacement vector S. This is a situation. Sir, ಹೆಂಗ್ ಬರುತ್ತೆ displacement vector? Simple. So first I should know the position vector here as R1. Then I will be knowing the position vector as what? R2. Now if you apply your triangle of vector addition, what will happen? Sir, OA plus AB, take the first two vectors in the same direction, then third vector will be the resultant. OA is nothing but R1, AB is nothing but S, OB is nothing but R2. So I got displacement vector S is equal to R2 minus R1. That means I should know about the both position vectors. Now let me take here what is R1. R1 ಅಂದ್ರೆ position vector. Position vector ಅಂದ್ರೆ ಏನಪ್ಪ? ಈ coordinates ನಾನು ಬರೀಬಹುದು. ಏನಿದೆ ನನ್ನ coordinates? 3, 2, -1. 3 ಅಂದ್ರೆ ಯಾವುದು? X component. I can write as 3i cap. Next 2 ಅಂದ್ರೆ Y component. Next -1 into K cap. Negative signs ಬಹಳ important. Okay, you should not miss that. Next R2. R2 value will be equal to X component. X component is nothing but X coordinate. X coordinate is to the -1. Then it will become -i cap plus 3j cap minus 4k cap. Now let me write the displacement vector. S is equal to what I can write R2 minus R1. What is R2? I have -i cap plus 3j cap minus 4k cap minus R1. R1 is how much I have? 3i cap plus 2j cap minus k cap. So -1 minus 3 I cap plus 3 minus 2 j cap, because I'm subtracting just by taking the corresponding components. Illi j cap 3 ಇದೆ, ಇಲ್ಲಿ j cap 2 ಇದೆ, ಮಧ್ಯದಲ್ಲಿ negative sign, that's why 3 minus 2. Illi -1 and this is -3. Next, this fellow will become -4 plus or minus of minus will become how much? Plus 1 into k cap. That's a story. Correct? So I will get how much? -4i cap. 3 minus 2 will become how much? J cap. -4 plus yeah. ಮುಂಚೆ ಕ್ವಶನ್ಗೂ ಈ ಕ್ವಶನ್ಗೂ ಏನ್ ಸರ್ ವ್ಯತ್ಯಾಸ ಅಂತ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ, ಇನ್ ಎ ಪ್ರೀವಿಯಸ್ ಕ್ವಶನ್ ಐ ಡಿಡ್ ನಾಟ್ ಗಿವ್ ದ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್.
Off your audio.
ಸರ್ ಆಡಿಯೋ ಬರ್ತಾ ಇಲ್ಲ ನಿಮ್ಮದು.
Mute ಆಗಿದೆ ನೋಡಿ ಸರ್, ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ.
ಸರ್ ಮ್ಯೂಟ್ ಆಗಿದೆ.
Yes, sir.
ಹಲೋ
Sound audible.
ಹಲೋ ಸರ್ ಆಡಿಯೋ ಇಸ್ ನಾಟ್. ಸಂದೀಪ್ ಸರ್ ಆಡಿಯೋ ಬರ್ತಾ ಇಲ್ಲ. ಸಂದೀಪ್ ಸರ್ ಆಡಿಯೋ ಇಸ್ ನಾಟ್ ಕಮಿಂಗ್. Sandeep sir, hello.
Not hear you, sir.
Sandeep sir, ಸಂದೀಪ್ ಸರ್ ಅವ್ರ ಮೊಬೈಲು ಎತ್ತ ಇಲ್ಲ ಸರ್.
ಸರಿ ನೀವು
ಉಮೇಶ್ ಸರ್, ಸಂದೀಪ್ ಸರ್ ಆಡಿಯೋ ಬರ್ತಾ ಇಲ್ಲ.
ಸಂದೀಪ್ ಸರ್ಗೆ ಅಡ್ಮಿಟ್ ಮಾಡಿ ನೋಡಿ ನಿಮ್ಮ ಕಡೆಯಿಂದ ಬರುತ್ತಾ ಇರೋದು.
ಮೊಬೈಲ್ಗೂ ಟ್ರೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಮೊಬೈಲ್ ಆನ್ಸರ್ ಮಾಡ್ತಾ ಇಲ್ಲ ಅವರು.
ಮಾಡ್ಬೋದಾ ನೋಡಿ ಸ್ಪೀಕರ್.
ಸಂದೀಪ್ ಸರ್, am I audible? Sir, please respond in the chat box.
Yes, sir. There was some technical glitch. Yeah, hope I am audible now. Yeah.
Yes, sir, 1 second sir.
Yes, sir.
ಸರ್ ನೀವು ಪ್ರೀವಿಯಸ್ ಇದು ಮಾಡಿದ್ರಲ್ಲ, ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಮಾಡಿದ್ರಲ್ಲ ಈ ಕಡೆದು, ಅದನ್ನ ಇನ್ನೊಂದ್ಸಲ ಮಾಡ್ಬೇಕಾಗುತ್ತೆ ಸರ್ ನೀವು, ಯಾಕಂದ್ರೆ ಅಲ್ಲಿ ಆಡಿಯೋನೇ
Mute
ಇರಲಿಲ್ಲ.
ಆಯ್ತಾ?
ಯಾ,
ಯಾವುದು ಆ ಡಯಾಗ್ರಾಮಾ?
ನಾಟ್ ಡಯಾಗ್ರಾಮ್, ದಿಸ್
Negative signs ಮೇಲೆ. Okay,
yes,
okay.
yes, yeah.
Fine, fine. Students, what I was telling here, see, if it is a competitive exam, you need not to solve all this much lengthy. What you can do, it is about only displacement vector I was just telling here. This is a position A, this is a position B, this is R1 and this is R2. The displacement vector is like this. So from the triangle law I have proved S is equal to R2 minus R1. This always works. But you need not to prove this in every time in your competitive exam. This you have to remember. How? Whenever I gave you about the two positions, displacement ಹೆಂಗ್ ತಗೋಬೇಕು ಅಂದ್ರೆ simple logic. Okay, final position vectors minus initial position vectors. ಅಂದ್ರೆ ಈ ತರ ನಾನು ವೆಕ್ಟಾರ್ಸ್ ಬರೀಬೇಕಾ? ಇಲ್ಲ, ಸಿಂಪಲ್ ಕೋಆರ್ಡಿನೇಟ್ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ತಾ ಬನ್ನಿ. ಇಲ್ಲಿ ಫೈನಲ್ ನಿಮ್ಗೆ ಎಕ್ಸ್ ಕೋಆರ್ಡಿನೇಟ್ ಎಷ್ಟಿದೆ? -1. ಇಲ್ಲಿ ಎಕ್ಸ್ ಕೋಆರ್ಡಿನೇಟ್ ಎಷ್ಟಿದೆ? 3. ಅಂದ್ರೆ -1 -3. That's a concept. Next here 3 and here 2. 3 minus 2. You will get directly here. -4 minus half -1. You will get -3. So that's how we can able to save that time in the competitive exam. Illa sir ನಾನು ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ಬರೀತಾ ಇದ್ದೀನಿ ಅಂದ್ರೆ you have to show all this particular part of it. So now once you got about this one, so what is the work done? If I ask you to calculate, so work done is equal to f dot s. So you can write x component here, product of corresponding x components 2 into -4. Here y component 3, here y component 1. So 3 into 1. Here x component 4, here -3. So 4 into -3. How much you got? -8 plus 3 -12. Correct? So you will get how much here? -20 plus 3. You would have got how much? -17 joules. So that is a story. So we discussed about work done by the constant forces here. What are all the possible mistakes the students will do? What are the procedure how you need to follow for the competitive exams? I could able to explain. Hope so things are clear. Okay, so follow the things. If there is any doubts, yeah, definitely you can always reach to us. Okay, thank you, and I'm really thankful to the organizers, okay, who gave me this opportunity to present myself. Okay, thank you so much. Hello.
ಹಲೋ
Yes, sir. From my side, yeah, I have completed,
Yes, sir.
sir.
Yeah,
Yes.
thank you very much, sir.
Thank you, sir. Thank
That
you.
was a very brief explanation about the force and different types of force, how the force comes, all these things. So, on behalf of all the students and on the behalf of the all the officers in KSTA, the President S. Ayappan, CEO AM Ramesh, and the organizer Siddhegowda sir, including all other officers and staffs, I would warmly thank you from the
Thank you, sir.
bottom
Thank you,
of
sir.
my heart for contributions. Thank you very much, sir.
Thank you,
And
sir.
if
Thank you,
there
sir.
is any further questions, we will let you know, sir, through
Definitely, sir.
email and mobile number, sir,
Yes, sir.
so
Yes,
that
sir.
you may answer to the students directly.
Definitely, sir. Definitely, that will be my pleasure. Yes.
Yeah, I'll be moving to the another presentation, sir.
Fine, sir. Fine,
Thank you
sir.
very much
Yes,
for
sir.
joining
Thank
us,
you,
sir.
sir. Thank you.
Thank
Thank
you.
you.
Thank you.
Bye.
Thank you. Dr. Naveen, sir.
Yes, sir.
Sir, I have given you presenter option. Please share your PPT, sir.
Right, sir. Fine.
Yes, sir. Thank you very much. I'll give a brief introduction about you to the students, sir. Is that fine?
Yes, no problem. Not required. I can introduce myself. Not no issues for that.
Now, warmly welcome to you on behalf of KSTA, all the staff and president and the students here, sir. I welcome you warmly to this presentation. I'll just give you one, two sentence of brief introduction about you, sir,
Just
if you
thank
don't
you.
mind. Yeah, then later you may continue about yourself.
Yes, fine.
Yeah. So, Dr. T. Naveen Kumar is an academician who has completed Masters in Chemistry from Kuempu University, Shivamoga, and PhD in the same stream from the same university. Hard working and tough task maker also, who always tries to achieve the goals within the deadline. Um, Experience in teaching nearly for 2 decades. So I'm very sure he has a wide range of students since 2 decades in chemistry, teaching for different levels. So warmly welcome to you on behalf of KST, sir, and I hand over the stage to you for further presentation.
Thank you, sir. Thank you very much for your introduction. Start now.
Yes, sir, please go on.
Good evening, my dear students and KST officials.
Sir,
Yes,
sorry to disturb you.
yes,
Please use Kannada language as maximum because we have Kannada background students here.
yes, sir. Right. Hmm?
And you may use English wherever it is necessary.
Okay, okay.
Prefer Kannada, sir. Thank you.
Yes, sir. Sure, sir. Sure, sure. Yeah. For all the KST officials, chairman and CEO, as sir mentioned, I'm Dr. Naveen Kumar. I taught chemistry for almost all 2 decades for all the students from pre-university to PhD. I taught the chemistry for UC, BSc, bachelor's, and MSc, then even engineering students. Right. Now I am a professor and head for PG Chemistry, Surana College. It's an autonomous institution affiliated to Bangalore University. It located in Southern Circle. Okay, and discuss thing little bit topic like slide. So as you people know, chemistry is always application oriented. Chemistry, there are no rocket science in chemistry. Whatever going to see in our day-to-day life, that's we call as chemistry, right? Apart, it starts from day, morning, heat, when we run, walk, when we thought, everything is, we may observe one or two point regarding chemistry, right? While we're eating, drinking water, water is a mixture of OH minus and H plus ions, nucleotides, molecules, right? What I'm to say is chemistry is application oriented. ದಿನನಿತ್ಯದ ಜೀವನದಲ್ಲಿ ನಾವೇನನ್ನು ನೋಡ್ತೀವೋ ನಾವೇನನ್ನು ಕಲಿತೀವೋ ನಾವೇನನ್ನು ಮಾಡ್ತೀವೋ that's we called as chemistry, nothing else. Each and every point they have evidence in chemistry. No need to search for Google, no need to search for book. There are small incidents also that you get chemistry. Now, very small topic.
Sir,
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 I'm
I
audible.
think
Am I audible?
sir, you're audible, yes, but your voice is getting bass, sir. One and
Okay.
second, I don't know whether you're changing your slides or not because here nothing
No,
is.
I'm not changing the slide.
Okay.
Just I'm talking, sir. I'm not
Yeah,
changing.
your voice is getting little more bass, sir.
Okay.
Yeah.
Now it's fine.
Continue, sir. Yeah, if there is any problem, I'll interrupt in between.
Please, sir. No problem. Right. Emulsion. Emulsion are the mixture of two or more type of liquids. Where the one such as droplets are tiny or even ultra microscopic size. That liquid are of different types, liquid droplets type, the film types, and then ultra microscopic type. There are two types of liquids together, right? It's a immeasurable, and then which are distributed throughout each other. In a one phase, they are distributed, one in a liquid and other in liquid droplet. These are usually formed from components of liquid either in natural form or more often. Usually mechanisms such as the vegetation which is provided that this fluid mixture have two kind of mutual solubility, right? They have no mutual solubility in the two types of liquids or two or more types of liquids. So no two or more type of liquid means when it's one it's in liquid, another droplet form or the film form or tiny or micro ultra microscopic in form. They are dispersed or distributed among complete emulsion systems, right? They are not mutually soluble in nature. Emulsions are said to be stabilized by some of the agents forming film at the surface of the droplet. But that is called, see, it form a surface on the droplets area, right? Then that surface, it may give stability, right? That droplet becomes stable, or those which impart to them as a kind of mechanical stability. The unstable form of emulsion eventually spreads into two forms of liquid layers. Those stable emulsions are destroyed by destroying or by deactivating the emulsifying agent. I'll explain you later what is emulsifying agent, what is the role of emulsifying agent during the emulsion, right? For example, by the addition of appropriate third party substance or even by the process of freezing or heating, the stability cannot be, we are going to uh, break that stability by different techniques that I'll, in this complete presentation, I'll explain what is the property of the emulsion, the definition of the emulsion, and what is emulsifier agents, and what are the use applications of emulsion in a chemical and food industries, and applications are used for the emulsion, right? Some common emulsions are milk, where the dispersion of the fat molecules or droplets in the aqueous solution. Here, as we know, dispersion phase and dispersion media in the emulsion. Here fat molecules are dispersing phase, aqueous solution, water is a dispersion medium, and also butter, which is a dispersion of droplets of particle of an aqueous solution in the fat, right? The definition of emulsion is, as I mentioned, emulsion can be defined as collide consists of two or more non-homogeneous type of liquids. It's a mixture of two or more non-homogeneous types of liquid. It is immiscible. There are separate liquids wherein one of the liquid containing the dispersion of the different form of liquid. For example, in the butter, as I mentioned, the last slide, right, are milk, where the dispersion of the fat molecules or droplets are completely dispersed on aqueous medium in the milk, and the droplets of particles dispersed in the aqueous solution in the fat, right? There is emulsion that there's a two or more homogeneous type of liquid where one of the liquid containing the dispersion of the different form of liquid. The examples are so many examples. I give some few examples for emulsion. Emulsion basically consists of dispersion of two liquids. Two liquid means one in the aqueous form, another one is in droplets or layer form, are invisible with each other. It's not visible for one of the liquid as a dispersion medium, and the other will act as a dispersion phase. One, there are two or more phase liquids. One liquid acts as a dispersion medium, and another liquid will act as a dispersion phase. In simple words, emulsions are colloids, which both the dispersion phase and dispersion media are liquid. What I am going to say is, in milk, both are the liquid, even droplets distributed among the liquid or water aqueous solution is dispersed among the milk. All both are in the liquid, right? That liquids are immiscible in nature. It dispersed means distributed among the milk. Oil and the mixture of water are also emulsion. Oil is dispersed completely, oil droplets in the water. When are shaken together, the oil forms drop and then disappears throughout the water. New oil, droplets of water is added to oil is added to your water. And you just take a water in a beaker, add around 10 drops of oil. You mix together by uh, using some instrument or glass rod and all. When we mix, that oil is completely distributed among the water solution. Okay, but it's not. Both oil and waters are uh, different stability. They are not mixed together. Oil forms a drop and it disappears throughout the. We will see the droplets of the oils throughout the water. The term emulsion is also applied to a group of mixture systems called as solution. It's a solution. Two or more liquid solutions is called as a emulsion or gel or suspensions. Take for example, the photographic emulsion is a gelatin gel consists of tiny crystal dispersed in the air. A gel containing a crystals. The crystals also dispersed among the complete photographic emulsion gelatin gel. Some other examples of emulsion includes butter, as I mentioned earlier, which is an emulsion of water in fat, and a glue containing lactic in states of different dispersive phase and dispersion medium. The type of color is emulsion. Where the examples is here dispersion phase is solid. Some of the colored glasses dispersion phase is of solid, dispersion medium is solid type. Gemstones preparation, this solid is three phases are solid, dispersive phase, liquid. Okay, type of color is solid. Okay, self flow aids, and then for solid and smoke exhaust, you may observe gas. Okay, right? Liquid is a dispersive phase. Dispersive phase is solid. Colored type is paste. Is a cream or the emulsions like this solid. Right? That liquid is both dispersive phase and cream. Fat is and water is in dispersion medium. Right? Then liquid, gas, insecticide sprayers. That sprayers aerosol in aerosol collide. That liquid is a dispersed phase and dispersion media is gas. Here there are different types of dispersion phase and dispersion media. Okay, in emulsion, the dispersed phase is also liquid, and then dispersion media is also liquid. It's a mixture of two or more liquid. Okay, and stable, both are in stable state, right? Liquid gas and gas solid, and then gas liquid. Foam is the foam collide is the mixture of dispersed phase as a gas and dispersion media as a liquid. Okay, right. For soap, lather. These are the different colloids are used day to day life, right? Then these are all say solid and gel, emulsion, foam. These are all the colloids, but this emulsion having a different properties. There are properties of emulsion. Emulsions containing both the continuous and the dispersal with the boundary coming between the phase that are called interference. Now, interference, say this as containing both dispersal with the between the interference between the liquid phase and other liquid phase during the emulsion process. Emulsion having a cloudy appearance due to many phase interference, scattering of light passing through the emulsion. And what I can say is this is light scattering property of the emulsion. Okay, emulsion appears in white color when the light is dispersed in equal propagation. In the emulsion is dilute, then higher frequency and the low wavelength type of light will be scattered in more fraction. And the kind of emulsion will be appears in blue in color. This is also referred as a Tyndall effect. This Tyndall effect is explained on the basis of scattering. Light is in different wavelength. If the properties will change, right? Then I preparation of types of emulsion. This is very important. Dispersive phase, the fat.
ನವೀನ್ ಸರ್, ಹಲೋ
Yes, sir. Yes, sir.
ಸರ್, ನವೀನ್ ಸರ್, ನಿಮ್ಮ ವಾಯ್ಸ್ ಬರ್ತಾ ಇಲ್ಲ.
Hello, am I? Hello.
ಸರ್, ವಾಯ್ಸ್ ಬರ್ತಾ ಇಲ್ಲ ನಿಮ್ದು.
Hello. ಇಲ್ಲ ಮ್ಯೂಟ್ ಆಗಿಲ್ಲ ಸರ್.
ಇಲ್ಲ, ಮ್ಯೂಟ್ ಆಗಿಲ್ಲ, ಆದ್ರೆ ನಿಮ್ಮ ವಾಯ್ಸ್ ಬರ್ತಾ ಇರಲಿಲ್ಲ ಸರ್.
Now.
ಇಟ್ಸ್ ವೆರಿ ಲೋ ಸರ್.
1 minute, sir. 1 minute. Yes, sir. I'm audible now.
Yes, sir. Yes, sir. Continue, sir, please.
Fine now.
Yes, sir. Yes, sir. Continue.
Emulsions can be classified.
Hello.
Hello.
Sir, again it's going off and coming back like that. It's on and off, on and off.
Types of emulsion. Now it's fine. It's fine.
Sir, it's going, it's on and off, sir. It's not clear. Hello. Hello. Hello, sir.
Fine, sir. Hello.
Yes, sir. Fine.
Now it's all right.
Yes, sir. Yes, sir. Be in the same direction, sir, for audio.
No, I'm not changing any direction, but
Yeah. Thank you.
maybe some technical problem. Sorry for the
Yes, sir.
inconvenient.
Continue, sir. Please continue.
Yes. Emulsion can be classified on the basis of property of dispersive phase and the dispersion medium, right? Here, as I told, the dispersion phase and dispersion media as a milk as an example. Take an example. Dispersion phase is in milk is the dispersion medium is water. Here is importantly first one is oil in water, okay, right, and water in oil. Here there are two phases. One is dispersion phase and dispersion type of emulsion. The oil will be the dispersion phase media. The best example for water emulsion is milk, fat, okay, which acts as a dispersion phase, and the suspended water, which acts as a dispersion medium. Okay, always the dispersion medium, water, the oil is spread across the water. Then water in oil. In this type, water will be the dispersion phase and oil will be the dispersion media. Okay, right? A spread used by example, water in oil emulsion. The margarine is an example for this. This is the mainly two types of emulsion: oil in water and then water in oil. These types are classified on the basis of properties of the phase, dispersion phase, and the dispersion media. There's emulsifying agents. there are the substances which are added to emulsions for stabilization purpose. The various characteristics of emulsifiers are given below. See here that as I told, in the emulsion process there are two phases. One is both are invisible to each other. Okay, and also they are having different properties. They are insoluble in each other. They are having their own stability, right? That to increase, to which added to the emulsion for stabilization. This is the emulsifying agent used to add to emulsion for the stabilization process. The characteristics of the emulsifiers are they are a substance which have hydrophilic and and hydrophobic end. The hydrophilic end and hydrophobic end means hydrophilic end means attracted towards the H plus, and hydrophobic means reflected towards the water or H plus. There's this characteristics of stabilizing agents like emulsifying. It increases the stability of the emulsions. Okay, they are soluble in both water and oil. As we know, there are emulsions, oil in emulsifying agents are soluble in both water and oil. Then it increases the stability of both the phases, right? Dispersion phase and then dispersion phase. Here is the important characteristics of emulsifying agent. Emulsifying agent is used to add or increase the stability of the different phases in the emulsion. Right. Emulsifier from the form a layer between the dispersive phase and the dispersion media. Dispersive phase particle separated. Okay, right. Emulsifying agents are used for stabilization. Okay, prevent the collision between the emulsifying media and the dispersion media and dispersion pair. That prevention, it gives a layer between the dispersion media and the dispersion phase. Okay, emulsifier can be cation, anion, or even non-polar. Anything is, whether it is positively charged or it is negatively charged or it is non-polar activities, right? It is not just a percentage of water and oil which decides whether it is in oil in water, or these emulsifying agents are useful to determine which type of emulsion it is. If this one is when we are the identification of or separation of emulsions, whether it is in a water and oil type of emulsion or oil and water type of emulsion, at that time it decides it's play an important role. On the other end, it depends on which among water and oil can be solvent. The emulsifier to a large extent. If the emulsifier is more stable in water, then the water becomes the dispersion medium, and oil become the dispersion phase, and hence we will get oil in water emulsion. It's vice versa. See, the water become the dispersion media and the oil become the dispersion phase. This the emulsifier is soluble in water. If the emulsifier is soluble in oil, then the oil become the dispersion media and the water become the dispersion phase. Right, that emulsifying agent increases their stability. On the other end, if the emulsifier is more soluble in oil, then it becomes the same thing. The commonly used emulsifier for oil water emulsions are proteins, derms, and soap sets. Right, the commonly used emulsifier for water in oil emulsions are heavy metal salts of fatty acids, long chain alcohol, etc. Because this metal salts, fatty acids, and long chain alcohols, these are all soluble in the water. Then the water is acts as water is a dispersion media. We commonly used emulsifier for some of the common examples for emulsifier are APO, sodium phosphate, mono and diglycerides, cellulose, then lactins, etc. These are all used to increase the stability of the particular see how the emulsifier, as I told, emulsifier is added to a what we called that emulsion to increase the stability, right? And that how the emulsifier work in that emulsion. Firstly, we need to understand the process of what is that? The process in which similar particle in the emulsion come together to form a larger and bulkier particles, leading to the separation of dispersed phase and the dispersion medium. So the similar both are in liquid phase. The similar particle in the emulsion come together to form a larger and bulkier particle, leads to the separation of the dispersion phase and dispersion media. Emulsifier helps in preventing collision or forming a physical barrier between the disappears phase and disappears dispersion media. See, commonly when oil is added to a water or water is added to an oil, the similar both the phase and then or else we will take milk as an example. As I told, milk containing droplets of fat and then aqueous solution of water. Both are in liquid phase. Then the number of bulk of the more number of particles comes together, they mix together, it forms a that emulsifying agent, okay, to prevent a barrier between the both the phases, like the water phase and then that dispersed media and dispersed phase. As well seen before, emulsifier like soap has both hydrophilic end and hydrophobic end, the water attractive end and water reflective ends, and they can attach to both polar and non-polar substances. What I am going to say is it gives a barrier between the two liquids, two liquid phases. One is a phase of dispersion medium. The dispersion medium strength is more when compared to the dispersion phase. That gives a barrier that easily differentiate that two particular. This one, this is example for sodium citrate. It can be represented as this hydrophilic end and hydrophobic end. Hydrophilic end, this is a negatively charged. Okay, it ready to attract the positive charge ions present in water. Okay, it will move towards the this when this is added on this is the same. See, this is a emulsifier, stabilizing agent, sodium. This is added to a emulsion type of oil and water emulsion. Molecules of this surrounded by the oil droplets, which they are non-polarized and hydrophobic end, the hydrocarbon chain, and extended into the oil and their polar ends, hydrophilic ends. Okay, that it forms a carboxylate ion facing the water as given in the serial. Hydrophilic ends, oil droplets. Inside you will get oil droplets. Here hydrophilic end and hydrophobic end. This is an hydrophobic end. Okay, right. Here oil droplets. Here hydrophilic ends. Okay. This arrangements bring a stronger adhesive force between the oil. Here in this case, oil is a dispersed phase. Okay, right? This oil and water emulsion. and water is a dispersion medium. The new formed adhesive force will more than the cohesive force between oil and water. Okay, right. Hence, oil particles will not have the tendency to come together to form larger particles. There are repulsion force between the oil and water. They have no question of tendency of to come together to form a large particles of oil droplets, and then to prevent the formation of oil mixture or water, then the stability of this emulsion increases. That means it that stabilizer or the emulsifiers to prevent the oil and water cohesive, the oil and water mixture. They have a cohesive force between these two oil and water because of this hydrophilic end and then hydrophobic end present in this. For water oil emulsion, the orientation of emulsifier would be opposite to the oil and water. That is non-polar, hydrophobic in nature. Hydrophobic end. This is hydrophilic end. Then, when we want to identify water and oil emulsion, we are going to use now hydrophobic end is extended out and the polar hydrophilic end. Hydrophobic here hydrophilic end and then hydrophobic end. There it's hydrophobic end and hydrophilic end. The phase inwards. There are the different process and mechanism, both chemical and physical, involved in the process of emulsion. There are several theories that uh, explain the theory, the emulsification. That is mainly surface tension theory. This theory states or describes emulsification as a process that occurs by the reduction of interfacial tension between two phases. Okay, there's a theory and all we have to explain with the clear derivation and explanation. The only the thing is emulsifying agent and classification of for the students who are learn now. They have to know what is the emulsifying agent and then what are the types of emulsions, what is dispersion phase and dispersion media. That's very important. That is the basic thing you should know. If you know all those things, you can easily understand the surface tension theory and repulsion theory. See, these theories that they describe the emulsification as a process that occurs by the reduction of interfactional tension between the two phases. But as I told you during the properties, okay, scattering technique, some other effects, the interference between the two phases, the barrier between the two phases, that cannot be, that are all explained on the basis of surface tension theory, right? And then repulsion theory, when this theory, we learned that emulsifier agent produces a film over one phase, which further leads to formation of globules. These compounds tends to repel each other, and the repulsive force that exists between them help them to remain suspended in the dispersion media. That means, say that repulsion theory explains this dispersion media and the dispersion phase are remains the same. They are not their property cannot be colloidal or interface or visible, right? That the methods to identify the type of emulsion. Okay, dilution test, for example, of foam and then milk, whatever the product, we can explain what type of emulsion is this, whether it is oil, water, or water oil. And adding water to an oil water emulsion, it will still remain stable as water in the dispersion media. But on adding oil, it will get disturbed, disturbed based on oil, right? Completely distributed on the oil and water are invisible. Similarly, water and oil emulsion can be diluted with the oil. would still it be stable, but would get same distribution on the addition of water. Okay, we can identify to make use of a dilution test in adding water to an oil water emulsion, it will still remain stable as a water. We can identify whether it is oil water or water oil technique. This is conductivity test. In this test, as we know, conductivity is measured in the case of the conductivity cell. That conductivity cell consists of two electrode kept in 1 centimeter apart and 1 centimeter cross section area. Okay, then they will keep it a bulb connected to the circuit as shown in the diagram. On the oil water emulsion will conduct electricity as a water conduct electricity as water conducts electricity, but water and oil will not conduct electricity. Water and oil will not conduct electricity, but oil and water conduct electricity because the water is the aqueous media or the dispersion media. The water is the dispersion media. Water is always conduct electricity because, as we know, the conductivity value is depending upon the very less, the highly mobility ions, H plus ions present in that H plus ions, okay, depending upon the number of H plus ions present in that and the mobility of the H plus ions present in that, water will get conduct electricity, right? Or it conduct electricity due to the presence of the conductivity is more because of presence of H plus ions. But in oil, there are no question of this. The conductivity is less in water oil emulsion because oil there are no H plus ion. It's a the media is a oil and phase dispersion phase is water and dispersion media is oil. Always the dispersion phase is very less content and then the water media is a more thing. That's what the oil cannot conduct the electricity. On the basis of electric conductivity, we can differentiate whether it is water oil emulsion or oil water emulsion. See, this is we are taking the particular example and explain. In this way, we are going to identify the different types of emulsions. This is the one of the technique to identify the type of emulsion. Same as conductivity dilution test. In addition, in adding water to the water and oil and water emulsion, it still remains stable because the water is the here the oil is a dispersion media, the water is a dispersion uh, phase. Okay, right? Then there is stable water in this dispersion media, but in adding oil it will get established as oil. Have you understood this? This is a little bit complicated understanding during the identification of type of emulsion. For the conductivity test, no complication because the water media, the media is water, it conducts electricity. We can easily identify it's a water and oil or oil and water. Okay, see the water contents is more, the media is water. We can easily identify the what we call what type of in a dry test. In this test, a water soluble dye is added. Dye test, water soluble dye is added to the emulsion. If it is an oil and water emulsion, the dispersion media appears red and the dispersion phase colorless. Okay, if the same dye is added to water and oil emulsion, here oil and water emulsion, okay, the dispersion media appears to be colorless and the dispersion phase appears to be a red. Okay, right? Or the dye shows a different characters on oil and water. That is a very important test to identify then separation of emulsion, the difference method by which emulsion can be separated into constituents. Okay, right? The phase can be separated by different methods. Liquid includes heating, centrifugation, freezing. That and all. Let's when we eat that the phase of the dispersion phase and dispersion media will be separated out and centrifuging, that means it will completely mix you will get the different method separated the constituents present in that the included liquid included in that emulsion, right? Then the applications of use of emulsions or emulsions are very much famous field of science and right, like the dyeing industry, plastic industry, synthetic rubber, cosmetics, pharmaceutical industry, personal hygiene, micro emulsion are used to deliver. Then this is used for vaccinations for killing various microbes, and then it's used to chemical synthesis mainly in the manufacture of polymer dispersion and use it for firefighting. And nano emulsions such as soybean oil are used for kill micro. That means in the health field or else in the field of medicine, they are used as uh, emulsion for the applications. These emulsions used in this all the type of plastic and organic industry, synthesis industry, and this is the emulsion technique and process. It comes under surface chemistry. If we know about the dispersion, the surface chemistry, surface colloidal phase, and then dispersion media and dispersion phase, basic things, we can easily identify the emulsion and the applications of emulsion and types of emulsion and the methods of emulsion. That is the thing. For the explanation of emulsion requires 4 or 5 hours for complete the basic, and then this is a little bit dry subjects. Uh, the applications of this emulsions are more, but the preparation and usage, that is little, and properties are little bit complicated. Anyway, I hope you understood something about the emulsion, and then thank you for the opportunity to explain the immersion technique for the students. Sir, thank you, sir. Hello?
Hello, sir.
Hello?
Hello, sir. Hello, sir.
Yes, sir. Yes, sir. Yes, sir. From this, I conclude my session. Thank you for the opportunity. Any questions regarding this? May I audible?
Yes, sir. I am looking for questions, sir. Please wait.
How can you find that participants? It is possible to find the participants here in this screen.
No, sir. It is
Oh, you
only for
people are
host.
visible, right? I'm not able to visible.
Yeah, sir. Thank you very much for giving your session. It was much insightful for students as well as for me personally. And for further proceedings, I hand over the stage to Umesh Gadge, sir.
Okay.
So, Gadge, sir, please welcome. Thank you.
The next session is that. Shall I exit or
No,
what?
sir. No, sir.
A lot of thanks, sir.
Thank you, sir. Thank you.
Gadge, sir, your voice is very less.
Can you hear me now?
Can I stop
Yes,
this?
sir. Yes, sir. Yes, sir.
Sir, very good evening. Very good evening to one and all. First and foremost, I would like to thank Dr. T. Naveen Kumar, sir, for accepting our invitation to deliver on behalf of KST and on behalf of all the teaching faculty. And thank you very much, sir, wholeheartedly.
For your invitation, and thank you for the inviting us for the technical talk. Thank you very much.
Also, I would like to thank our colleagues, technical team and non-technical team who are behind this. And last but not least, I would like to thank all the teachers and students who have joined in WebEx Cisco platform as well as in. Thank you. With this, we will conclude today's session. Thank you very much.